Hello everybody. This is chapter 4, review number 1. Question number 1 says, which ordered pair is not a point on the graph y equals 1/2 x minus 7? So what's going to happen is one of these is not going to satisfy the equation. It's not going to make the equation true when I plug in the numbers for x and y. So I'm going to go ahead and start here. So we're going to start with A. And you might want to do this on a separate sheet of paper because it's going to take a little bit of room. If I start writing down y equals 1/2 x minus 7, now I'm going to plug in my x and y and say, does it equal each other? Do the two sides match or equal? So y in the first case for A is -6.5 equals 1/2 times x, which is a 1, minus 7. So this is -6.5. Does it equal 1/2 minus 7? Well, you can do that on your calculator. 1/2 minus 7 is -6.5. Okay, if you like to do it with decimals, you can go ahead and change it to -6.5. But you'll see that that makes this true. And we're looking for one that's not true, so it's not A. Let's check B. Writing down the equation first, so we know what we're plugging into. This time the x is -2 and the y is -8. So we have a -8 equaling 1/2 times our -2 for x minus 7. Is this going to be the same? Well, the left side is already a -8. Let's check the right side. 1/2 of -2, you can do it on your calculator if you need to, but half of -2 is just -1 minus 7, and -1 minus 7 is -8. So this one was true as well, so it's not B either. Let's go ahead and do C. Okay, y equals 1/2 x minus 7. We're going to plug in 0 for x and -7 for y. This one's pretty easy. Does it equal? Well, the left side is already simplified at a -7. Half of 0 is still 0. And 0 minus 7 is still -7. So we think it's going to be D, but we got to check just to make sure. So far, it's worked for all equations, and we're trying to find one that it doesn't work for. So x and y, x is 2, y is 8. We're going to rewrite this and plug in our x and y. 8 equals 1/2 times our new x, which is 2. Does it equal? Well, the 8 is already simplified. The other side, we can take half of 2, which is 1, and then subtract 7. And of course, 1 minus 7 is -6, which does not equal each other. So which one does it not work for? It would be D. What is f of -2 if f of x is 1/2 x? All you're doing is plugging in -2 every time you see x. I see it once here, and I see it there. So f of -2 equals 1/2 of x, which is -2. F of -2 equals half of -2, which is -1. Okay, you can write it like that. I saw some people on the other quizzes writing out the x and the y. So if you write it as an ordered pair, you know the x is what you plugged in, which was -2, and the y, which is what you got out, was a -1. Either one of those answers is fine. Number 3. The graph at the right shows Jeremy's distance from home each hour he's on a car trip. How many miles will he be from home after 10 hours. So we have a graph which we can get an equation from. Okay, so look at these points. We need to know the slope. What does it go up by every time? You can use the 2 points, 1 comma 50, and the second point 2 comma 100, and you can find slope that way using the slope formula. N equals y2 minus y1 over x2 minus x1. Okay, so we have x1, y1, x2, y2, and I'm just going to plug them in. 100 minus 50 over 2 minus 1. And that is 50 over 1, which is just 50. If we know our slope, we can look at our y-intercept, and if you look at this graph, I can see that it's going to be going down. It keeps going down, and it will hit 0. You can double check. As I'm going down on the y's, I'm going down by 50 each time. So take away 50 from 50, I'm going to end up with 0. And as you go down here, 4, 3, 2, 1 would be 0. So I would get 0, 0 would be my y-intercept. So the b is just 0. Okay. And then we can write our equation. So we have, I'll write it over here, y equals 50x plus nothing. And how many miles? Miles is the y. We're looking for y. Will he be from home after 10 hours, which is the x? So we're plugging in 10 for x and finding y. So y equals 500 miles from home after 10 hours. Which table represents a linear function? Linear functions, you're writing this down, has the same slope everywhere. So you're just checking the tables to see if they have the same slope. Let's check the first one. Let's see, we're going down by 2 and down by 2. So that's, okay, that looks like -2. We always do y over x. So we're going to have a -2 over -2, which is a 1. Okay, so that's 1. Let's do the next one. Looks like we're going down 2. We're going to go, oh, this one's a +2, isn't it? Who caught that? This is supposed to be a +2. The y is a +2, so this is actually a -1. Sorry. -1. All right, this is going up 2, down 2. Looks the same so far, right? That will reduce also to a -1. And then here we're going down 2, and here we're still going up 2. So as you can see, all of these y's over x's are all going to be equal. The y's over x's are the same. So that one is linear. And is that what we're looking for? Which table represents a linear function? Yeah, which one has the same slope everywhere? That's this one. Every time there, everything I highlighted has a slope of -1. We can double check these. Okay, as you see here, we're going up by 2. This is going up by 1. So that slope would be, change in y over change in x is 1 over 2. Don't forget to put the y over the x. And this one would be up 2. Okay, you see how that one is now going to be 2 over 2, which is 1, and 1 does not equal a half. So that is not linear. Okay, you're looking at the y over the x, the change in y over the change in x. And we can double check the other ones. Right, so we're going to go up by 3. This one looks like it goes up by 2, but this one goes up by 5, while this one goes up by 2. So 3 over 2 does not equal 5 over 2. That's why that one doesn't work. And this one up by 2, down by 3. This one's going to go down by 3, and this one goes up, down by 3. Okay, so and again, y over x, so 2 over negative 3 does not equal negative 3 over negative 3. So that's why that one doesn't work either. So the answer is F. Let's see, we've got a monthly cost of sending text messages can be represented by the function y equals 0.05x, where y represents the total cost and x represents the number of text messages. The table shows Tanya's monthly cost of sending text messages. So we have Juana and we have Tanya. So let's label this here. Let's do this. So her text messages are represented by this, right? And Tanya's monthly cost of sending text messages is in the table. So I'm going to label this Tanya, and we're comparing. Okay, it says which statement is not true. We have A, B, C, D. We want to know if Tanya's initial cost is greater than Juana's initial cost. So this initial cost is the B. We're comparing B. Tanya pays more per text than Juana. That's comparing M. And then C and D, you actually have to plug in a number and see what you get out. So plug in a number, see what you get out. So we really have to figure out equations for both of these. We already have Juana's equation is y equals 0.05x. And we can find out Tanya's equation by going like this. Okay. Two ways to do this. I'm going to do it the way we've been doing it this year. So I'm going to go ahead and say y minus y1 equals m times x minus x1. You can just temporarily plug in an x and a y to find b. But of course, either way, we have to find m first. M is the slope. It's just the change in y over the change in x. So the change in y looks like it's going up by 1. The change in x up by 10. So the slope is 1 over 10. I'm going to go ahead and make that a decimal. You can do it on your calculator. 1 divided by 10 is 0.10. Okay, so that's the slope. And I'm going to go ahead and plug in my x1 and y1 into this formula. So y minus y1, which is 10, equals the slope of 0.10 times x minus 20. All right, we're going to distribute here, leaving me this side is the same. We have 0.10 times x, that's 0.10x, minus 0.10 times negative 20 would be a negative 2. Okay, and then we're going to go ahead and get y by itself. We need to add 10 to both sides. So y equals 0.10x plus 8. Negative 2 plus 10 is 8, positive 8. So that's our formula for, who is that now? We have Tanya. So this is Tanya. Okay, and up here we have Juana. Juana, Tanya. So let's see, we're comparing. Let's talk about A. Is Tanya's initial cost greater than Juana's initial cost? So Tanya is over here. Her initial cost is the y-intercept. Is that one greater than the one for Juana here, which, oops, you guys know, I'm supposed to be that. You guys know that if there's no plus b, it would be plus 0. So is 8 greater than 0? Yes, and we're looking for the statement that's not true. And A is true, so that's not an answer. We want one that's not true. So Tanya pays more per text than Juana. Let's look over here. Tanya pays more per text. Per text is the slope. So here's Tanya's slope. Is that greater, paying more than 0.05? Yep, 10 cents is greater than 5 cents. So that one is true, which is not an answer then. We're looking for one that's false. Let's look at C. All right, for Juana. We're looking at Juana. Okay, that's up here. Does she pay $7.50 when she sends 150 text messages? Okay, so we actually want to plug in the 150 to see if we get out a $7.50. So we have y equals 0.05. X, we're going to plug in 150 for X. And 150 times 0.05 is $7.50, or 7.5, which of course in money is $7.50. So that one is true, so it must be D. Let's double check that one. We have Tanya now. We're looking at her equation. I'm going to write that here. Y equals 0.10x plus 8. And I'm plugging in 150, seeing if we're getting out 20. All right. 0.10 times 150, that's 1.5. Plus 8 is going to be 9. Sorry, I just noticed this was 15. 15 plus 8 is going to be 23. So that one's not true, and that's what we're looking for, which statement is not true. Whew. Which of the following represents a non-linear function? Well, linear, you guys know, has x and y to the power of 1. Power of 1 here, power of 1 here, that's linear. Power of 1, power of 2, oh, there it is. These all have powers of 1 everywhere. All right, Nate has a certain number of songs on his MP3 player. Each week he plans to add 2 more songs. After 5 weeks, he had 25 songs on his MP3 player. Which statement is true? What do we have? What do we know? He has a certain number of songs on his MP3 player. We don't know the beginning number that he has, so we don't know the B. Okay? Y equals mx plus b. We don't know the B. But we do know each week he plans to add 2 more songs. When we use that keyword each, we know we're talking about the slope. So we know the m is 2. And we also know a point because after 5 weeks, he had 25 songs. So that is our point 5, 25. And we can use this to find our equation, and that will help us solve this. So this is our x1, y1. I'm going to go ahead and use point slope form. And then I'll rearrange it. So y minus y1, which is 25, equals the slope m, which is 2, times x minus x1, which is 5. Distribute the 2. I have y minus 25 equals 2x minus 10. And add 25 to both sides to get it in slope-intercept form. 2x plus 15. All right, now that it's in slope-intercept form, let's see what we have. A says, when we're looking for a true statement this time, so pay attention, he adds 5 songs on his MP3 player per week. Keyword, we're looking for the slope. Is the slope 5? No, the slope is 2. So not A. Let's see, B. Does he add 10 songs per week? Is the slope 10? No, we know that's not true. Is the initial number of songs in Nate's MP3 player 15? Yes, he started with 15, okay? And the other one said he started with 2. So that would be C. State the domain and range for the following. Domain is all the x's in numerical order. So starting with -4, then we have a 0, 1, and 3. And the range is everything else in numerical order. I have 2 2's. I only have to write them once. 2, 3, and 4. Complete the function table. All right, that looks better. Okay, complete the function table for f of x equals -2x plus 1. So when I plug in -2, you have -2, I'm just rewriting this, times x, which is -2, plus 1. This is a +4 plus 1, which is 5. Okay, now let's plug in 0. Let's write this here. This is f of -2. F of 0 is -2 times 0 plus 1, which is 0 plus 1, which is 1. Go ahead, we're going to plug the third one in. F of 1 equals -2 times 1 plus 1, which is -2 plus 1, which is -1. And f of 2, we're plugging in the last one here. So here we go, the x is 2. So that's -4 plus 1, which is -3. Okay, for exercises 10 and 11, consider the following situation. The grocery store sells cantaloupe for $4.50 per pound. Write a function to represent the situation. I'm going to use, let's see, cantaloupes. Do you want to use, I'll just use x and y. Y equals, the total cost y equals $4.50 per pound. $4.50 per however many pounds they have. Is the function continuous or discrete? And honestly, this one can be argued either way, okay? So the way the book wants you to do it is to say, since it's per pound, and technically per pound you could have fractional amounts of pounds, and I guess you could cut up cantaloupes and buy fractional amounts, it will be continuous. Okay, so we're going to say continuous because you can buy fractional amounts of pounds of cantaloupe. We want to graph y equals 2/3 x minus 2. I'm going to go ahead and use slope intercept for this one, but you can also make a table. If you're going to make a table, you want to use multiples of 3 when you plug it in. So I'll set you up for the people that want to do the table We have x, we have negative 2/3 x minus 2, and y, and all you're going to do is plug in multiples of 3. 0 is easy, and then maybe try 3 and maybe 6. You really only need 2 points, but practice. Try those 3 points. I'm going to use slope-intercept. So using this equation, my slope is negative 2/3, and my y-intercept, my b, is negative 2. So I'm going to begin at my negative 2. So my first dot is at negative 2. And my slope says to go down 2, and we always run right 3. Well, we always run to the right anyways. So from there, down 2, right 3. Now this, you're only having those 2 big dots, so ignore the little dots. That was just me showing you where I was going. So the 2 big dots is what we want on our graph, and you're going to connect the dots with a big line that goes everywhere through the graph. Arrows on either end. Because it's a line, the solutions go on and on forever. Remember, every one of these are possible solutions. Okay, and 13, I think it's getting in my way. The value of a painting has increased steadily over time. Sketch a qualitative graph to represent the situation. So we need to label this, okay? We have the value of a painting's increasing steadily over time. Time is almost always here. We can label time here and maybe value up here. Okay, and if it's increasing steadily, it's just rising. Now I'm going to not start right here because I'm assuming it didn't start off at a value of 0. I'm going to start it up a little bit higher. So saying it's starting somewhere here, we're not going to label the numbers on it. We're just going to do something like that. It could be like that. You could have also done something, didn't have to look exactly like that, but that's fine. If it rises steadily over time, it's at a constant rate. I believe that's it.